Hello, this is Mrs. Sarkis again, and I picked out a really complicated problem to explain how to decide if the physician's order is suitable or not. So as a nurse, it's your responsibility to make sure that you are not harming the patient. So let's read this problem and kind of unpack it. So the physician orders 2 milliliters every 4 to 6 hours of Tylenol 3. The child weighs 50 pounds, and the label states there's 15 milligrams of codeine in every 5 milliliters of the liquid, and the safe dosage is between 0.5 and 1.5 milligrams per kilogram per dose, presumably of the codeine, every 4 to 6 hours. Is the physician's order suitable? So the first thing we need to look at is there's so many things going on here. So let's look at the frequency. So the frequency of the order is every 4 to 6 hours. And the safe dosage is also given as every 4 to 6 hours. So you don't have to worry about the minimum of 4 and the maximum of 6, because the order frequency and the safe dosage frequency are the same. So then what we really need to do is to compare that 2 milliliters to the safe dosage range, which is between 0.5 and 1.5 milligrams per kilogram per dose. And that's what we need to do. Now the problem is that 2 milliliters is different from 0.5 to 1.5. So it's milliliters versus milligram per kilogram per dose. So we need to do some unit conversions. And it's acceptable to look at it at the milliliters and convert it back to milligrams per kilogram per dose. But I think it's a little easier to understand to look at the minimum and maximum dosage. So I'm going to start by writing the minimum safe dosage, and I'll do the maximum safe dosage. And then we'll just do unit conversions from there. So the minimum safe dosage is 0.5 milligrams per kilogram per dose. And the maximum is 1.5 milligram per kilogram per dose. Okay, so when I see that kilograms in there, I know that means kilograms of body weight, but the patient's weight is given to us in pounds, so that's actually something we need to do first, is convert that 50 pounds into kilograms. And I'll put pounds on the bottom to get rid of the pounds. Kilograms goes on the top. 1 kilogram is 2.2 pounds, so we need to do 50 divided by 2.2. The pounds cancel, and we end up with 22.72 repeating. And that's in kilograms. And at my institution, we round the kilograms to the nearest tenth. So we're going to use 22.7 kilograms. So the first thing I'm going to do is to take that minimum and the maximum safe dosage, do one at a time, and multiply by the 22.7 kilograms. So that'll give us milligrams per dose. But that's going to give us milligrams, so we also need to convert. Let's see, we know that the strength here is 5 milliliters goes with 15 milligrams. So 15 milligrams in every 5 milliliters. So I want to get rid of the milligrams in the top, so I'm going to put the milligrams in the bottom, and it's 15 milligrams in every 5 milliliters. So that gives me, cancels the milligrams, and the units that are left standing are milliliters per dose. And that's what we got here. This is milliliters per dose. So now we just need to do the arithmetic here. So it's 22.7 times 0.5 is 11.35. Multiply by 5. And then that gives me 56.75 in the top. And in the bottom it's 15. So that gives me and that's milliliters per dose. So that's going to be 3.783 repeating milliliters per dose. Now, those of you who are really understanding what we're doing here, we already know that the 2 milliliters is below the minimum safe dosage, so we really already have the information. But when you're telling somebody else that they have made a mistake in the prescribing information, I think it's best to go ahead and do all the calculations just to be sure. So let's go ahead and do the rest of it, even though we already have the answer to the question. So we're going to do the same multiplying by the patient's weight, and then using the strength of the drug to see what we need to calculate here. So that it cancels the kilograms here, and the milligrams cancel here. So now we've got milliliters per dose. So this is going to be 1.5 times 22.7 times 5 is 170.25 divided by 15, and that's going to be milliliters per dose. So the maximum safe dose is 11.35 milliliters per dose. Now you may have noticed that I didn't do any rounding, and that's because this is the minimum and this is the maximum. You're not going to give the patient either one of those. You're going to give the patient what the doctor ordered if it's safe. Or you're going to tell the doctor that their order, or whoever the prescriber is, that their order is not safe because it's not in between these two numbers. So since these are not actual dosaging, it's okay to have a weird number in there. So what's really going on here is this 2 milliliters per dose is not in between these two. So if we would like look at this on a number line, you know, the minimum safe dose is over here at 3.783 repeating milliliters, and the maximum safe dose is 11.35 milliliters. So the safe dosage range is in between these two numbers, but the 2 milliliters, the order, so this is the minimum and this is the maximum safe dosage, but the order is over here at 2 milliliters. That's the order. So therefore, the order is not safe because 2 milliliters is not between 3.783 and 11.35 milliliters. Okay, and the reason why it's okay to compare these is this is milliliters for a dose. This is the minimum number of milliliters for a safe dose, the maximum number of milliliters for a safe dose. So this is an underdose. So that is some information you would need to bring to the prescribing physician and to show your work clearly to explain to them what's wrong so that they can do something about it.